Hello Year 11, it's the assessment today. The only reason why I'm recording anything is because I'm going to read through the assessment. So this is entirely optional. If you would like to watch this video and listen to me reading through the assessment, that's great. If you'd just like to do the assessment on your own, then don't watch this video and just crack on with it. So here's the folder and here's the assessment. I'm going to use the one that is on my desktop because I'm going to edit it slightly. So I'll say it again. What you can do for me is, if you are here to watch me read it out and listen to me reading, I won't pause between questions. You can pause the YouTube video and you can resume it when you're ready. So let's get started. I would recommend having a highlighter, even if it's just the highlighter that is in Word. So, question 1. The diagram shows two forces acting on an object. What is the resultant force acting on the object? Tick one box. Is it 8 newtons to the right, 8 newtons to the left, 4 newtons to the right, or 4 newtons to the left? Remember, just pause it if I'm going too fast, which I will be, and then resume it when you're ready. B. Base jumpers jump from very high buildings and mountains for sport. The diagram shows the forces acting on a base jumper in flight. The base jumper is wearing a wingsuit. Draw a ring around the correct answer in the box to complete each sentence. The base jumper accelerates forwards when force A is blank force B. So is force A smaller than, equal to, or bigger than force B? The base jumper falls with a constant speed when force C is blank force D. So is that smaller than, equal to, or bigger than force D? To land safely, the base jumper opens a parachute. What effect does opening the parachute have on the speed of the falling base jumper? Give a reason for your answer. Question 2. The diagram shows a life belt. It is hanging freely from hook Y. On the diagram, mark with an X the point where you think the center of mass of the life belt will be. So on this diagram, mark with an X where you think the center of mass will be. If you are doing this on a computer, go on to Insert, Shapes, and then choose a shape. There is actually a little X shape somewhere, which I can't see for some reason. So just get any shape, little diamond. There's a little diamond. Okay, and then position it wherever you think the center of mass is. Explain why you have chosen this point. Okay. Question 3. Choose the words from this list to complete the sentences below. Balanced, electricity, gravity, joules, magnetism, newtons. When you drop something, it falls. This is because it is pulled to the earth by blank. We measure forces in units called blank. When a falling object reaches the ground, it stops moving. This means that the forces acting on it are now blank. Question 4. The diagram shows the forces on a small, radio-controlled flying toy. So here you've got the lift force pushing upwards, and you've got the weight pulling downwards. The mass of the toy is 0.06 kilograms. The gravitational field strength is 10 newtons per kilogram. Calculate the weight of the toy. Show clearly how you work out your answer and give the unit. As a hint, you will need an equation for this. If you do not know, you can guess the unit of the weight, and I'll get you 1 mark. Part 2. Complete the following sentence by drawing a ring around the correct line in the box. When the toy is hovering stationary in midair, the lift force is bigger than, the same as, smaller than the weight of the toy. B. When the motor inside the toy is switched off, the toy starts to accelerate downwards. What does the word accelerate mean? What is the direction of the resultant force on the falling toy? So while this toy is accelerating downwards, what is the direction of the resultant force? Question 5. A student suspended a spring from a laboratory stand and then hung a weight from the spring. Figure 1 shows you the spring before and after the weight is added. Measure the extension of the spring shown in figure 1. So you've got to use this ruler here. Don't use your own ruler. Use this ruler here. And I'd probably draw lines across so that you could measure the extension in millimeters. B. The student used the spring, a set of weights, and the ruler to investigate how the extension of the spring depended on the weight hanging from the spring. Before starting the investigation, the student wrote the following prediction. The extension of the spring will be directly proportional to the weight hanging from the spring. Figure 2 shows how the student arranged the apparatus. So you've got a ruler, you've got a spring, you've got a weight, and the ruler is going like that. Before taking any measurements, the student adjusted the ruler to make it vertical. Now, vertical just means straight up and down. Explain why adjusting the ruler was important. So why was changing the ruler from being like this to being straight up and down important? C. The student measured the extension of the spring using a range of weights. The student's data is shown plotted on a graph in figure 3. So you've got the weight in newtons, okay, and then you've got the extension in centimeters. What range of weight did the student use? So range, same as the mathematical term. Why does the data plotted in figure 3 support the student's prediction? And the prediction, I'm going to scroll up, is there. This is the prediction. So I'll have a read of that, and I'll have a read of that question and see if you can tell me why. Part D. Sorry, I've done part D already. Part E. Describe one technique that you could have used to improve the accuracy of the measurements taken by the student. So this is 2 marks. So say what the technique is and say why. Part F. The student continued the investigation by increasing the range of weights added to the spring. All of the data is plotted in figure 4. At the end of the investigation, all of the weights were removed from the spring. What can you conclude from figure 4 about the deformation of the spring? So let's have a look at the graph. You've got weight and you've got extension, and you notice the graph goes like this, and at some point it changes. What happened to this spring is what this question here. This question is saying what happened to the spring, and this question is asking why has that happened? And that is the end.